In this short video, we'll be talking about decluttering code, removing extraneous or long-winded things from the code to make it easier to work with. All of the code you're going to see is available in this GitHub repo, and each of the commits in that repo will demonstrate one of the versions of the code as we move through. And the idea is to look at some of the simple techniques that can make your code more terse and therefore more clear, and how monolithic things, when broken into smaller pieces, become easier to work with. So here's our initial code, which is some sort of string processing algorithm which appears to pass its tests. And as you can see, the first thing about it is it's very deeply indented. If you turn your head on one side and look at it, it's like there's a giant pyramid in the middle of the screen. So let's try and handle that as we go through. And as we can see, two ifs at the beginning, cascading, are essentially trying to be an and, but the hard way. So let's take that out. So that's a lot clearer than it was. Next, there's a pattern here which involves declaring a variable at the top of a function and then manipulating it in the middle if you're allowed to do processing, and then returning and a single return point at the end. And that's something of an anti-pattern in that this function decides in its first if statement if there is an answer or not, and yet somehow has to make use of a temporary variable for the entire lifetime. So the value of result at the very end there could be the value of doing nothing, or could be the value of calculating something. And it's a lot clearer to reverse that guard condition and get out early if there's no processing that you can do. So now we're saying if there's no way that we can process it, let's return an empty list. So that has now divided the function into two halves, the no calculation and the do the calculation half. Next, we've got final all over the place, which is not really necessary, though final has a place in Java. In this particular case, it's not adding a huge amount, and it's probably better to use methods like having short functions rather than trying to protect yourself from overwriting the value of references. So let's remove final as well. Again, makes the code less noisy, less busy. You can see what's going on. So next off, the main problem with this function is it's operating at all levels of abstraction, and in the middle of that loop there is the technique for calculating whether or not to add one of the source strings to the resulting list. And in fact, there's even a bug. It turns out that result.add can happen multiple times for the same source string if it matches multiple words, which we couldn't quite see before. And clearly this is what this is trying to do, is operate on each of the items in the source and decide if it's in the result. By extracting a method there, we immediately are able to separate it into manageable pieces, and that bug goes away. And in fact, that bug evaded the tests, which is an interesting example of what happens when optimistic tests meets complex code. So, okay, we now have a much clearer separation between the thing running through the list and the thing deciding what to do with each item. And in fact, this thing running through the list, producing the result, is a classic filter one list to produce another, and we can express that as a stream. So that's much clearer now. We have the guard condition for the empty list, and we have the filter condition inside the stream for when there is a list of things to process. And in fact, what's going on inside this matches function is in itself another stream operation. So we can replace that with a streaming operation too. Again, much cleaner, much simpler, and the declarative benefit of streams is helping us there. Now we have a little bit of code soup to look at in the bottom. Jumps off the page. It's doing some sort of magic, but I have to parse that and execute it in my mind in order to know exactly what it's doing. If we give it an explanatory function, we can now see, it's deciding if there's a word match going on in there with no case. So that is the source and the destination. We go from this deeply nested everything to all people kind of function to a series of small components, each of which adds up to make the algorithm and has fewer bugs in it as well. And that's how to declutter your code.